Okay, looking at a harder example using first principles. Here we need to find the derivative. In other words, we need to differentiate this curve. F of x equals x squared plus 4x. So it's a parabola that's the right way up, it's shifted away from the origin, and we need to use first principles. So after we've done that, we're going to find the gradient of the tangent at a specific point. So looking at part A first, every time you differentiate using first principles, start by writing the formula. That way, it'll become entrenched as a habit and you'll remember it. Take the limit as h approaches 0 of function of x plus h minus the function of x all over h. Now, if you need to have a bit of a think over on the side, what is the function of x? Well, it's given to us up here. Some people find it handy to jot these things down on the side. If you don't need to, that's fine. What is the function of x plus h? Well, that means anywhere they've used an x in this formula here, we need to use x plus h. So that means we need to do x plus h all squared, and then we need to add 4 lots of x plus h. Okay, so that's what we're going to need to put in to our formula on the next line. I might just switch colours so it's a bit easier to see. Okay, so on the next line, take the limit as h approaches 0. We haven't taken the limit yet, so every time we haven't taken it, we need to write down that we're going to take it. Now the function of x plus h is, in this case, x plus h all squared plus 4 lots of x plus h. And that's because our formula says x squared plus 4x. So we need to sub in x plus h anywhere there's an x. Then we need to subtract f of x itself, and f of x itself is just this part. Now here we don't want to make a mistake. I'm going to rub out this part because we've used it now. We're subtracting something that's got 2 parts. So put the thing that you're subtracting, x squared plus 4x, that's just our function of x, put it in brackets so that we don't make a sign error with this minus sign here. That whole thing is over h. Alright, on the next line, let's expand all our brackets, and then on the line after that, we'll tidy it up. So expanding x plus h all squared, we've got x squared plus 2xh plus h squared. Expanding this part, we get plus 4x and plus 4h. And now we've got the minus sign here, which means we have minus x squared and minus 4x. That's a key spot that a lot of people mess up, accidentally putting a plus there, but that negative makes this one negative. Whole thing is still over h, and we can't take the limit as h approaches 0 yet because h is still on the bottom of a fraction. Next step, we have to tidy up. We haven't taken the limit yet, so write it down. Now we have an x squared here, but also a minus x squared there, so they'll cancel. We've also got a plus 4x here and a minus 4x there, so those will cancel. So we're left with 2xh plus h squared plus 4h all over h. Now you've got 2 choices here. You can either just divide each of these 3 terms by h, extract an h out of them, or you could factorise the top. If you factorise the top, you'd bring an h out the front, and you'd have 2x plus h plus 4, and the whole thing would be over h. And you can see there that the h's are going to cancel. Whichever way you prefer to do it, whether you actually put this line next, with your limit of course, or whether you can just naturally take an h out of each thing there, the next line is going to be, take the limit as h approaches 0 of 2x plus h plus 4. Okay? Now, our h is not on the bottom of a fraction anymore, it's just floating here. So on the next line, we can actually take the limit as h approaches 0 and say, alright, what would this expression be if the h part was pretty well as close as you can get to being 0? Well, we'd really just be left with the 2x plus the 4, wouldn't we? Because we're adding something that's so small it's virtually disappeared. So on the next line, I'm going to take the limit as h approaches 0. So I won't need to write it again because I've already thought that through. And I'm going to say I'm just left now with 2x plus 4. So I've finished at this point. I've found the derivative using first principles. Now what does that mean? Well, this is a little formula here for a function that tells me how I can find the gradient of this curve at any point that I want to investigate. So for part B, they've told me to investigate this point, the point 1, 5. Now the only part of this information that I need is the x value. Here, x is 1. The fact that it's 1, 5, I don't really need the 5, I just need the 1. So, if I want to find the gradient when x equals 1, I can just sub 1 in to my gradient function, because this is a gradient function now. And that means instead of using x's, I'm just going to use 1. So I'm going to have 2 lots of 1 plus 4. So I've got 2 plus 4, which is 6. So the answer to this question is, therefore, gradient at the point 1, 5 is 6. So it'll be quite steep at that point. And that's how you differentiate something by first principles.